Today's Daily Dose of Math is about graphing a quadratic equation, but of the form y equals ax squared, which is one of the simpler forms of the quadratic equation. In this question, we're being asked to graph y equals 1/3 x squared in the interval -2 to 3. In this other one, we're being asked to graph y equals -2.4 x squared in the interval from -1 to 2. In this interval, the 3 is not included, but the -2 is. In this interval, the -1 is not included, but the 2 is included. If you're familiar with your interval notation, then you're not surprised by that. To do this type of quadratic is pretty quick, simply by making a table of values. So that's one of the methods that we can use to graph this, and it's the one we'll use today. What I'm going to do is I'm going to find all of the points where x is a whole number in between -2 and 3 so that I can see that whole interval shaping up on my graph. If x is -2, x squared is -2 squared, which is +4. And then that +4 is multiplied by 1/3, and I have 4/3, or 1.33 if I prefer decimals, in my table of values. Remember, BEDMAS says that we do the exponent before we multiply. So I square my x value first, then I multiply by 1/3. If x is -1, -1 squared is +1, and +1 times 1/3 is 1/3, or 0.33. Now I am rounding these. If x is 0, 0 squared is still 0, and 0 times 1/3 is 0, so we have the point 0, 0. Well, whenever you have an equation of y equals ax squared form, you will always have the point 0, 0 in your table of values. If x is 1, 1 squared is 1, times 1/3 is 1/3. We're getting the same thing that happened with -1. If x is 2, 2 squared is 4, 4 times 1/3 is 4/3. We're getting the same thing that happened with -2. And we shouldn't be surprised by that, because we know that when you square a negative number, you get a positive answer. And finally, if x is 3, 3 squared is 9, 9 times 1/3 is 3. We have enough points so that we can draw a graph. Excuse me for not using a ruler. But I make a graph. Now I have to scale it. I need to make sure on the x's that all the numbers between -2 and 3 will fit. Pardon me for this not being drawn perfectly well. And then for our y values, all of our y values are between 0 and 3. So everything should be able to fit on this graph the way I've scaled it. The point 0, 0 is here. -1, 1/3 will be about here. +1, 1/3 will be about here. And of course, with a quadratic, we get a mirror image of developing around the axis of symmetry, but in this form, it will always be an axis of symmetry, which is the y-axis. -2 4/3 is going to be about here, and +2 4/3 is going to be about here. Finally, 3, 3 is the last point that I have. And then I draw my curve. I'm drawing a parabola. I'm not trying to draw straight lines here. And it's not drawn very well because of the fact that I'm trying to draw it on an upright whiteboard. But we're able to see the shape of our curve. Finally, what we have to do is go back and look at the question again and remember that we are only being asked to graph between -2 and 3. The -2 is included. So I put a solid dot at x equals -2 on my curve. The 3 is not included. I'm removing the portions of the curve that were to the left of -2 and to the right of 3, but they're not, because they're not included in the interval that I'm supposed to be graphing. And this 3, I can't have a solid circle there. I have to have an open circle because it's not included. Now I'm finished graphing y equals 1/3 x squared in this interval. Let's do another example. We're using y equals -2.4 x squared, and we're in the interval from -1 to 2, so I only need 4 points to show the whole numbers between -1 and 2 on the x-axis. Negative 1 squared is positive 1. 1 times negative 2.4 is negative 2.4. 0 squared is 0, and 0 times negative 2.4 is still 0. So again, we get the point 0, 0. 1 squared is 1, and 1 times negative 2.4, of course, is negative 2.4. And we see our mirror image showing up again in this table of values. 2 squared is 4, and 4 times negative 2.4 is negative 9.6. I have enough points so that I can graph this now. I draw a graph. And I scale it so that I can make sure these numbers will fit. So I'll put negative 2, negative 1, positive 1, positive 2 on my x-axis. I want to make sure negative 9.6 will show on the y-axis. So I'm going to do, say, negative 5 and negative 10. I should have enough scaling so that all of these points can fit. 0, 0, of course, is right here. 1, negative 2.4, well, I put my number 1 in the wrong place because it's in the way. Negative 1, negative 1, comma, negative 2.4 will be about here. Negative 1, negative 2.4, it's happening again, will be about here. And 2, negative 9.6 is going to be about here. Now I can draw my curve, but I'm remembering the interval again. Negative 1 is not included in this interval, so I don't need a solid dot there. I need an open dot. And that connects to my vertex at 0, 0. And this goes down to here, and then I stop because I've reached positive 2 on the x-axis. It's included, so it's a solid circle, but I don't continue my curve past there because of the interval I was asked to graph within. So this is 2 examples that show how to graph a quadratic of the form y equals ax squared when you're given an interval to graph between. And the method of creating a table of values is a very effective way of doing this. That is today's Daily Dose of Math. Please subscribe and share, and hit that thumbs up button.